variable resistor. Here is 3 pins. If I put the voltage on the left pin and the right pin, I will measure the voltage that I have in the middle pin resistance to see what's happened when I turn this potentiometer. The plus red on the red side here and the minus on the blue side. So I measure between the red and the blue, and we see that we have 8,18 volt, which is a little bit too high to work with UNO. I will reduce this to 5 volt. To reduce my output from 9 volt to 5 volt, I will use this little circuit, which is wonderful. You have a button on off. When you push on, you have the light is on. If you have the jumper left, like this, and like this, you have an output of 3,5 volt. And you have 3,5 volt there, and you have 2 pins of 5 volt. You can use directly this pin to have 3,5 volt of 5 volt off. You can use this between this pin and this pin. But you can also have directly the 5 volt jumper from the left side to the right side. Then you have 5 volt output. Now I will not go in detail of that. You make an alimentation 9 volt battery to the jack connection here. Or you can also connect with the USB here to your PC, and you have also the input from the PC. I will use this only to put the 5 volt constantly on my board to be sure to not destroy the Arduino UNO. So, if you can see, I have the 9 volt battery connected to the jack connector. This stabilizer of voltage is on, and I have connected the ground to the black, and to the red I have connected the 5 volt. You can really see here 5 volt and ground. This red connector go to the red side of to the red line of my breadboard, and the black connector to the blue line of alimentation. So I have theoretically 5 volt between the black and the red, but in fact I have 4,94 volt. The card is the power is giving to the breadboard, and the resistor is working as I have shown you before, and the output of the resistor, so the middle point of the resistor is going to the A02 on the Arduino. At the same time, I have taken the ground from the breadboard and put to the ground of the Arduino. And the Arduino is connected to my USB, and I have made a program, and the program is running now. You have now the Arduino UNO, which is powered by the USB cable connected to my PC. I measure now the potential between this middle cable, which is connected to the plus of my meter, and the voltage on the null minus cable. So when I turn the resistor, I have this, I have this potential going to 494 until in the other side to null. Let's go to null. Yes. Now I will apply this middle potential to the Arduino UNO and to see what we can do with. It like it, and like this I start it again, and I have still fast. Yeah, maybe it's better if I compile again. I compile again, and now I send programmation to the board. It's done updating, and I will start the serial monitor again. I stop it, I start it, and it's more better. Okay. Now I have a value of 0. You can see that the value is 0 and stable. I will put the potentiometer anti-clockwise. Depends if clockwise. It depends if you look the potentiometer in the front of behind. So you see that now the value is much more stable and is 430, 436, 41, 47. So we go from 0 to 106. Let's go again in clockwise or anti-clockwise, depends where you look. I go to the other side of the potentiometer to see the maximum value. And the maximum value, I will start again the monitoring. It's easy. Serial monitoring, stop. Serial monitoring, start. I go to a maximum value of 106. Normal, it must be 1035, I think, theoretically. But okay. It's 1002. Let's go fast to the other side again from the potential. Pin button is an integer and it's coming from the A2 Arduino board. It means that I connect the resistance variable to the middle port rheostat to the middle port to the A02 from the analog point of measure from the Arduino board, which is the potential value. I measure the potential value given by this middle point of the rheostat. I declare also a loop sketch, which is a loop, and I initialize it to 0. After that, I go to the setup. I set up the serial port from 9600 baud, and then I loop. I print, serial print \r. We want to say that I bring the printout just after each other without return to the line. I read the potential value by an analog pin port from the UNO. I increase the loop sketch by 1. If the loop sketch is bigger than 9, I do again. If it's bigger than 9, mean 9, I go to I print NL to go to return to the line, and I initialize the loop sketch to 0. I wait 1 second and I do that again. Stop it. I start it. And I will show the value. It's maximum. It's 1005. Yeah, it decrease until it will reach 0. Voilà. I have to Yeah, is the minimum value is 0 and will stay 0 like that, except if I move again the potentiometer, voilà, I go back, it's increased again.